Hello, apes, and welcome to the ninth screencast in our Chapter 2 series. This is a long chapter. I know I can't wait to get over it, and we don't have too much more to cover, so hopefully we'll be able to finish it in this screencast. What if I were to tell you that every day that there's an earthquake, that there's earthquakes that are happening so far below the Earth's surface that you can't even feel them. But if we were to look at a seismograph, which is the machinery that detects earthquakes, we would see subtle shifts in quakes that are happening all across the world. So most earthquakes are barely perceptible, but the one that happened to hit Japan in 2011, this was an extremely powerful earthquake, enough so that there was significant losses of human life, and there was a lot of damage to the property that was there in that particular area. Damage is going to generally be greatest where soils are loose or saturated with water, and going to be in areas where cities build on top of landfill. They're particularly susceptible to earthquakes. In 1989, there was the Loma Prieta earthquake that shook San Francisco and Oakland, and there was a baseball game going on for the World Series, and it was one of the hardest hit areas. They actually felt the shake at the World Series. There was another major earthquake in the San Francisco area in 1906 that was quite disastrous as well. So earthquakes, just giving you a few idea of earthquakes, they release energy or pressure that are along plate boundaries, or what we call faults. And there's different kinds of earthquakes that we will be talking about. We know that they can do tremendous damage to life and property. Buildings that are old buildings that were built before the current technology that we have tend to crumble. That's why earthquakes in underdeveloped countries or poorer countries, they lose so much, because their buildings, one, they don't have the income, and their buildings aren't built to withstand the earthquakes. But now we're able to retrofit buildings so that it decreases the amount of damage when earthquakes hit, that they kind of sway with the movement of the earth. So the buildings then are designed to be more flexible, and of course, in order to do this design, they're much more expensive. So the poorer nations, as I said, they don't have those protections. So when an earthquake hits in those areas, it's potentially problematic for them. When we think about volcanoes, volcanoes are also another area of destruction. They arise from rifts that happen in subduction zones and hot spots, like we talked about. They form when molten rock and hot gas or ash erupts through the Earth's surface, and then it cools and creates a mountain. So when we take a look at any areas like Hawaii that has volcanoes, then we can see the distinct mountain ranges. And I talk about Costa Rica, and I'll be going and drawing on that experience quite a bit. But when I went to Costa Rica and we were on top of Mount Arenal, which was just amazing, and I'll show you some pictures of that in class, as I said. You're standing on top of where lava was running, and it's fabulous. We had the opportunity to swim in the hot springs that were created from the volcanic activity beneath, which is another great thing to do. So there's hot spots that form over areas of lava, and that rise is from the mantle. The lava flow can be slow. Uh, Arenal, one time when it erupted, it was just a very slow eruption, and you could literally watch the lava coming down and sparks coming out, and it would cool down before it would reach any place where anybody would live, and then it could erupt suddenly. And that sudden is called the pyroclastic flow, and I had mentioned this to you earlier, and that's a fast-moving cloud of gas and ash and rock. Actually, it's how Pompeii was buried in 79 AD, and you've probably seen some film footage on that here and there for that. So volcanic eruptions really exert a lot of environmental impacts. For one example, the ash blocks sunlight. It also produces sulfur emissions that lead to the production of sulfuric acid, which is dangerous. It blocks radiation, and it actually cools the atmosphere. Mount St. Helena's, when that erupted, it was huge. It was just literally huge. I believe that was in the 1980s when that erupted, and there was ash that they said actually reached all the way to Pennsylvania that was in the sky. Another thing, and I know that from my experience with Costa Rica, the ash that came out of Mount Arenal contains silicon. And silicon is some of the stuff that we use in plastics. So there were planes trying to fly over and it was blocking the engines. People breathing, trying to breathe, and it was causing respiratory problems as well. So large eruptions can decrease temperatures worldwide. Mount Tambora is a very good example of this, and it happened in 1816. And they called it the year without a summer because the ash was so much that it created a chill in the area. Yellowstone National Park is an ancient supervolcano, and there's been a lot more activity this year at this supervolcano that they've been watching. The past eruptions were so massive that they covered much of North America in ash, and they're watching to make sure that they can predict when the next major eruption is going to take place, and the concern is it would wipe out all of North America because this area is still geothermally active today. Landslides can happen. We've heard about landslides before, and this is a severe sudden mass of wasting. So it can be rocks, it can be mud, it can be soil, and this just collapses, and snow, and this collapses and flows downhill. When we talk about mass wasting, this is the downslope movement of soil and rock due to gravity. So plants, trees, their root systems usually hold the rocks and the soil in place. But when we have construction and we have mountaintop mining, this produces greater amounts of mass wasting that happen. The rain will actually saturate the soils, and the root systems can't pick them up good enough because the trees most of the time have been taken out, and it triggers gigantic mudslides. I've seen pictures where houses are hanging off the edge of a cliff because they've been moved down by these mudslides. They erode and they create unstable hillsides, and of course they damage property, as I just said. It's caused by humans because humans are constantly altering the habitat. They're building on mountainsides. They're farming on mountainsides. They're cutting the mountainsides down for coal. So we actually loosen and expose the soil, and we create the problem. They can also cause massive damage because if there's weather that's coming in, you no longer have that I can't even talk today, protection. And in 1998, Hurricane Mitch, it killed over 11,000 people because of the mass wasting and mudslides that happened as a result. You've heard of tsunamis before, and tsunamis are tidal waves. Another way of talking about saying a tidal created by a tidal wave, and seawater is in massive volumes, it kind of hurls into the land. It happens as a result of earthquakes, volcanoes, and landslides as well. We've got a lot of ice breaking down from the Antarctica, and what's happening is when these big chunks of ice fall down, they can create a tsunami as well. And when tsunamis happen, like especially when an earthquake happens under the ocean, that just pushes the water up and it races the water to land in both directions. It's not just in one direction, it's both directions. So the damage from these can be very widespread and distant across coastlines. They can damage coral reefs, the kelp forest, the coastal kelp forest, and the wetlands that are so valuable as our nurseries. All and for nutrients as well. So all of these can be damaged. There could be saltwater contamination in our freshwater supply systems, and we've got agencies and nations that actually have buoys and things placed out in the ocean to give residents enough advanced warning about approaching tsunamis. So if we know that an earthquake does happen, we can make a prediction of when the tsunami is going to hit, and we can watch for it. That happened a couple of years ago, and we watched the coastline of Hawaii because they were expecting one, and it kind of fizzled out, which was good. But we knew to expect it, and people were warned, and they moved away from the coastlines. It also helps us in ways of preserving our coral reefs and our mangrove forest, so that can decrease the wave energy from the tsunamis. And that's one of the reasons why we need to preserve those areas. We face and affect other natural hazards like flood and coastal erosion and wildfire and tornadoes and hurricanes, so those are other problems. Overpopulation is a big problem. People tend to live near the coastlines and they're more susceptible. We choose to live in the attractive but vulnerable areas, the beaches and the mountains. And engineered landscapes increase frequency or severity or hazards. Every time we dam rivers or we suppress fire or mining, that has an impact. And we're going to talk all about these in later chapters, so I'm just kind of hitting the surface here. And we wind up, with all of this, we wind up changing the climate through the greenhouse gases. And these changes change the rainfall patterns. They increase drought in some areas. They increase fire and flooding and storms. So we can decrease these impacts and hazards through technology and engineering and policy and informed geology and ecology. So that's what we need to do, and that's going to be the goal this year, is to make you informed. We can build earthquake-resistant structures. We can design early warning systems, as we talked about. We can preserve the reefs and the shorelines. That's huge. We've got to do that now, even to protect the biodiversity. And we can have better forestry, agriculture, mining, that will prevent some of the hazards. We've got to have regulations and building codes. We've got to have insurance incentives, and we've got to discourage building in vulnerable areas. And we've got to mitigate for climate change to reduce the natural hazards. So in conclusion, and we've got a minute left, so going quickly, solving environmental problems depends on our understanding of matter, chemistry, and energy. We have to understand the physical processes, the shape of our terrain, and the foundation of a living system. And we have to understand the geological processes that threaten us. These processes in one location can initiate events that impact more than that one location. All right, that ends this chapter. Whew, long chapter, running out of time. That means a test, your first test for the year. Wow. Okay, we'll talk about that in class. All right, see ya.